How can engine thermal efficiency be improved by design? Imagine squeezing more energy out of every drop of fuel your engine burns. That's what improving thermal efficiency is all about. It's like getting more miles per gallon without changing your driving habits. Engines convert heat from fuel into motion, but not all that heat turns into useful work. Some heat always escapes, wasting energy. So, how can engineers design engines to make better use of that heat? Let's explore some smart strategies. First, increasing the temperature difference between the hot and cold parts of the engine cycle can boost efficiency. Think of it as making the hot side hotter and the cold side cooler. In internal combustion engines, this means raising the temperature during combustion while keeping the exhaust gases cooler. Higher combustion temperatures mean more energy is available for work. To do this safely, engines use higher compression ratios, which compress the fuel-air mixture more before ignition. But there's a limit because too high compression can cause knocking, where the fuel ignites prematurely. Using high-octane fuels helps prevent knocking and allows for higher compression ratios, leading to better efficiency. Next, optimizing the compression ratio itself is key. The compression ratio is how much the engine compresses the fuel mixture before it ignites. The higher this ratio, the more work you get from each cycle. Modern engine designs use advanced piston shapes and combustion chambers to support higher compression ratios safely. This means more power from the same amount of fuel, making the engine run more efficiently. Improving how air and fuel mix and burn is another way to boost efficiency. Better airflow through optimized intake ports and valve timing ensures the fuel burns more completely and quickly. This reduces wasted energy and increases power output. Think of it like making sure every drop of fuel is fully used, not left behind as in burned residue. Reducing heat losses is also important. Engines lose heat through their walls and cooling systems, which wastes energy. Using better insulation materials or coatings on engine parts helps keep more heat inside the combustion chamber. Additionally, designing cooling systems that only remove the necessary heat prevents excess cooling, keeping more energy available for work. Some engines use special thermodynamic cycles that are more efficient than traditional ones. For example, the Atkinson cycle extends the power stroke relative to compression, extracting more energy from the same fuel. Variable valve timing also helps match the engine's operation to different speeds and loads, improving overall efficiency. Friction in engine parts is a hidden energy drain. Reducing friction with better lubricants and smoother components means less energy is lost overcoming resistance. This allows more of the fuel's energy to be converted into useful work. Finally, capturing waste heat can make a big difference. Devices like turbochargers use exhaust gases to compress incoming air, boosting power and efficiency. Some systems even convert waste heat directly into electricity with thermoelectric generators, making use of energy that would otherwise be lost. In essence, designing engines to be more thermally efficient involves a mix of increasing combustion temperatures safely, optimizing airflow, reducing heat and friction losses, and sometimes using clever cycles or waste heat recovery. These improvements help engines produce more power with less fuel, all while emitting less heat waste. It's a smart way to make everyday engines more effective and environmentally friendly.